Yo. Okay, 9.1. This is a review of our inequality section. We've already learned how to graph these. We've already learned how to solve them. We're going to review it again in our Unit 9, and hopefully it'll be fast. 1 through 6 are asking us to describe how you would graph it. In other words, what would the graph of this number 1 look like? What would that look like on the number line? Would it be an open dot? Would it be a closed dot? Would it be to the right, to the left?
Open to the left.
Okay, so it would be an open because there's no equal sign, right? So open dot at 3. So it'd be an open dot at 3 and shaded to the
Left.
Shaded to the left. Less than is right. I mean, yeah, it's less than. So shaded left. Basically what that means is all numbers that are less than 3 would be to the left of 3. Number 2, open, close.
Close dot to the right.
Yes, no? Agree? Okay, close dot at 1. Don't forget to say 1. Closed dot at 1. Shaded right. Number 3, not Avery. Give us some.
It'll be open dot to the left.
Open dot at 5 and to the left. Good. Open dot at 5 shaded left. Okay, Johnny's got the next one. What do you got for me?
Close dot at -1 to the right. Or left.
Left. Good. So that's right. Close dot at -1. Close dot at -1 shaded left again. Okay, Francisco, you had the next one for me? Ooh, this one's kind of a weird one. What would we do on this one? It looks to me like it's going to be open dots, because there's no equal sign, right?
And to the left.
So we're going to have open dots at 3. Wait a second. Why would they put... Oh, so it's both sides is -3. Open dot at -3. And then shaded both sides. So shaded both sides. Okay, that would be a weird looking graph. Let me show you that one. You'd have your 0, -1, -2, -3. You'd have an open dot there. And you'd be shading this way. And you'd be shading that way.
Oh.
So what would that be a picture of then? What would be the right and wrong answers?
Anything that was greater than there was no wrong.
There is a wrong answer. There's only one wrong answer. That's the one because it's an open dot. Where is the open dot located? -3. That's the only one that you could put into that X and it would not work. Everything else would work, but -3 is not less than or greater than -3. It's equal, and it doesn't say equal. So that would be 6. Number 7, it would be closed dots at -1 and 4. Oops, not -4. -1 and 4. And then you're going to shade everything in the middle. It's going to be less than 4 and greater than -1. So shade or shade in the middle of those numbers. So you want to shade in the middle of those two numbers. Everything in the middle would be shaded. So would 0 be a right answer?
Yeah.
Yeah, because 0 is between those two numbers. Anything between those two numbers and -1 and 4 are also answered because it does say equals. So that would be number 1 there. 1 through 6. That would use the first part. That's just to describe. The rest of them, you actually do the graph, so they'll be easier. All right, moving on. It's on video, so if you do miss anything, you can always go back later and watch it on the and see it. Okay, graph each inequality. So I've given you 7 through 12, and I've given you a place to graph it. So this will be your number line. So you could even put arrows at the end of the line there. Number 7, it says x is greater than -2. We should start at 0. I'm going to put 0 to the right a little bit. So I can put -1, -2, kind of like that. I could even make another one where -3 would be. This would be a 1, this would be a 2 if I wanted to.
Do you have to put in how many numbers?
No, you can put in as many as you need. Just need to show me where 0 is. And then show me where your -2 would be. You're going to use an open dot because it's not equals. So that means 2 is not a right answer. If I put a 2 there, it would be wrong. 2 is not greater, or -2 is not greater than -2. So it's got to be an open dot. Greater than would be all of these numbers. So some of you like to shade above the graph. Some of you like to shade on the graph. So you can shade it however you like. You just need to make sure you fill in the arrow. Filling in the arrow tells you it goes on forever. Number 8, we're going to graph x is less than 4. So again, you could put your arrows on there. This time I'll start over here on the left side at 0. Count over 1, 2, 3, 4. And Jackie, what kind of a dot? Open circle or closed dot do you think I'm going to put here? Closed, good, because it says equal, so that's going to be closed. And which way do you think I would shade? Left thing. Left or right? Left is right, good, left. Left is right. And this one, but it's not right, it's left. Okay, so you can shade above it. I'm going to shade above the graph, so you can shade on the graph if you'd rather. So that would be your answer to 8. 9, I believe that's a 5 underneath there. Yep, so x is greater than 5. So I'm going to start way over here on my left side at 0. Here you go. Zero on the left side, and then I'm going to count over to 5. Counting over to 5. Stephanie, what do you think? Open or closed? It's going to be open. Good, because open, because we did not equal to right there, so open. Right or left? Right is correct, because it's greater than. Greater than is always the right. Greater than numbers are to the right of the other numbers. Number 10. This one is where we have 2 numbers, so what do you think here?
Okay, so like you write 0 and 4, and then you put a dot on 0, an open dot over 0, an open dot over 4, and you shade it.
Okay, so open on 0 on 4 and open on 0.
Yeah.
Okay, good. It should be open. That's correct. And shade in between, because it's greater than 0, which means it's to the right of 0, but it's less than 4 to the left of 4. So if you're going to the right of 0 and you're going to the left of 4, they will meet in this middle part.
And you don't
So you don't actually even need arrows. You just draw straight across and you shade that in. That means there's only technically 3 whole number answers there. The only answers you could really say that you could fit in for x that would be whole numbers
1, 2,
would be 1, 2, 3. Yep. 0 and 4 are technically not right answers to that one. Number 11. We're going to go and put a 0 somewhere. I'm going to put 0 in the middle this time. And I'm going to put a 1 here. I need a -1, a -2, a -3. And I need some marks at -3 and 1. They're both open. Good. So they do not include those 2 numbers. Now it says it's going to be less than 1 whole, but it's greater than -3. So we're looking at the same scenario here. We're going to make sure it's all the middle numbers. It's less than 1 whole, It's x is less than 1, and x is greater than -3. So it would be all the numbers in between. And then the last one, we're going to put -4, -1. So I'm going to put my 0 over here to the right side. And I'm going to number my negatives. -1, -2, -3, -4. Again, they are... Ooh, there's one closed one this time, huh?
So close.
One closed at -4, but there's an open one at -1. So which one is a correct answer there?
-4.
-4 is a correct answer, and anything in between these, huh?
Yeah.
So the middle number. Those are all right answers. Okay, so that was just graphic. Just remembering what open circle means, what closed dot means, which way to shade, which way to go. A lot of times, if you've got the letter first, you could make this into an arrow, and it will show you which way to shade if the letter's first. If the letter's not first, then that doesn't work. But if the letter's first, you can see how it's kind of the arrowhead would be pointing to the right, so that would be to the right. All right, let's move to 13, if that's on there. I'm not sure. No, it starts over. Okay, write an inequality. So now we're going backwards. Then they're giving you the graph, and they want you to actually write down what the inequality would have been. So it's got an open circle at 3, and it's shading to the right. So how would I write that as an inequality? Let's use the letter X on all of these. So greater than eats the X, right? Greater than 3 is correct. Because it's all the bigger numbers. Greater than means bigger. And it's not equal to 3, it's just greater than. So it's got to be an open circle. Now this one, they did make a closed dot at -1. And they shaded everything to the right. So we'll use X again. Less than or greater than? Greater than, and is it equal to? Yes, it is a closed dot. So greater than and equal to -1. Third one has an open circle at +6. So we know we're going to be using X. We know we're going to be using +6. We're looking at less, greater, equal to, less equal
Greater
to.
than, less than.
Just less than, right? No, nothing else. So less than would be like an L shape almost. The L is turned a little bit. L is less than. The last one has the 2 dots. So you've got a -7. You've got an X in the middle, because you got all the stuff in the middle, and you got a 5 over here. What do you think?
This one, was that less than? Greater than?
Less than would be like an L.
Greater
So I'm thinking we want numbers that are bigger than -7, right? So that's greater than. That's going to go this way. Greater than or equal to. And we want numbers that are
or smaller?
smaller than 5. So less than 5. So they're going to be greater than -7, and they're going to be less than 5. So those would be the inequalities there. Okay, the back side. Let's take a look at that. On the back. Okay, write an inequality that will model each situation. So let's read it. There are 91 named mountains in the United States that are more than 14,000 feet above sea level.
Well, more means greater.
More means greater. Okay, so there are 91 named mountains in the U.S. that are more than 14,000 feet high, above sea level. Okay, so if we're talking about feet, then these mountains, M, we'll call it M, Our more than would be greater than, and then 14,000 feet. So that's going to say that basically the mountains that they're talking about, these 91 mountains, we'll call that M, are greater than 14,000 feet. So all those mountains that they have are greater than 14,000 feet. None of them are less. It doesn't say more than and equal to, it just says more than. So we'd have to use just the greater than sign. It takes Jim from 6 to 8 minutes to run a mile. Somewhere between 6 and 8 minutes to run a mile.
So we don't have to do
So we're going to have the 6 and the 8, right? We'll use M again for mile. And what do you think? It's got to be somewhere between 6 and 8.
So it has
So is it less than 6 or more than 6?
more than.
It's more than 6. So it's got to open to the M on that one. The mile's more than 6. Well, what else do we know about it?
It has to be less than 8.
Got to also be less than 8. So the M has to be greater than 6, but it has to be less than the 8. So this M's got to be somewhere in the middle of those two, the 6 and the 8. That would be an inequality to model. Okay, look at the next example that you see right here. It says write the set of integers greater than 4 in roster notation and in set builder notation. These are ways, this is why I need you to see this, because on a test, when you do like the computerized tests and stuff, they write things in these notations and you may or may not know what it means. So a roster notation is where they start listing numbers. You have to list at least 3. You see how they listed 1, 2, 3 numbers? Then you can put the 3 dots. What do the 3 dots mean? What would these 3 dots tell me? It goes on forever, right? It's like shading in your arrow. You put those 3 dots, it's going on forever. So that's called roster notation. This one right here, set builder notation. That one's a little more difficult to understand. Here it is right here. It says X, and this line right here is like the word such that. X such that X is an integer, and X is greater than 4. So X such that X is an integer, and X is greater than 4. Now if you look at the graph, you got 5, 6, 7. They made a dot at 5, 6, 7, 8, and it would keep going because they had the 3 dots. And you can see that these numbers right here are being described right here below it. This right here describes this set. All numbers greater than 4. What's the first number greater than 4?
5.
There it is right there. First number greater than 4 is a 5. So such that all X is an integer and X has to be greater than 4. So we're starting at greater than 4 and we're listing them all. And then we make the 3 dots and say that it goes on forever. So here's what it's asking for us to do. First 4, they want us to write it in set builder notation. So that means you're going to draw your little set symbol, X such that X is an integer, and X, and we got to look at our little set now. What is the set looking like?
Less than. So less than negative.
So negative 4 is less than negative 3? Negative 5 is less than negative 4?
Yeah.
Do they look less than?
Yeah.
They are less than because they're bigger negatives, right? A lot of times people would see this and they would think greater because they're seeing bigger numbers. But bigger negatives are always smaller. So this is going to be less than. And what is this less than? What's negative 3 less than?
Negative 2.
Less than negative 2. If it's an integer, it's got to be less than negative 2. So that would be 1 for our set builder notation. This one we would have X such that X is an integer, and X is what?
Greater than.
Well, there you got it. What do you think? Anybody else think they got something? David, what do you think? What is this greater than? What is 2 greater than? What's the next number below 2? 1. It's greater than 1. It's got to be all numbers that are greater than 1. So you would have x in it is an integer and x is greater than 1. Greater than 1 is would be our thing. There's not. There's another way we could have actually written it too. What if we put x is greater than or equal to 2? Would that have still worked?
Yeah.
Yeah, because it does equal 2 and it's greater. So I could have actually used either one of these two and it would have been okay. I think what they want is this one. But you could have used either one. Let's look at this one. Now it's a little tricky. X such that x is an integer and oh wait, no, hold on. We got to add an extra word in there. There's another word we need to add. Look at the numbers. What word comes to mind when you see these 3 numbers?
Odd.
Odd. So, and 7, because that's the next one, but these are odd numbers, right? So x such that x is an odd integer. It's got to be an odd integer. We're doing all odds. And x, how about we write is positive? Would that work? Could we just say all positive odd integers? Because this starts at 1. We could have said greater than 0. We could have said greater than or equal to 1. Or we could have just said x is positive. Because we're looking at all positive odd numbers. So there's a lot of different ways you could have described this. You could have described that set. A lot of different ways. Alright, here's one that says x such that x is, let's see, now x is even. X is even. Anything else we need to write?
No.
It looks like they're all even, both ways, right? Positive and negative. So x such that x is maybe we should put an even number. Because this is talking about all even numbers there. So that would be describing it for us. That's called set builder. The last one is called roster notation. So we want to actually write the first 3 numbers that we would use here.
-1.
X is an integer and x is greater than 1, greater than or equal to 1. Not 1, greater than or equal to 0, sorry. Greater than or equal to 0.
So 0.
0 is going to be starting. Then 1, because the next number is 1. The next integer would be 2, and then you could put your 3 dots. Once you've got 3 numbers, you could then put your 3 dots. Okay, try number 6. And then look at the board and see if you got it right. It says x such that x is an integer, and x is less than or equal to -1. So see if you can come up with the first 3 numbers and then the 3 dots. It's an integer, and it's less than or equal to -1. Check and see if you got the same answer that I did once you're done. It's got to be less than or equal to -1. So your beginning number would be -1 because it says it could be equal to. So your beginning number is -1. Then we're going to do all the less than numbers. -2 is less, -3 is less because they're bigger negative. Try 7. X such that x is a whole number and x is greater than 0. It's got to be a whole number. It's got to be greater than 0. Check it out and see if you got the same thing I got. Greater than 0 means you don't put 0. Whole numbers means there's no fractions or decimals. So you're just going to do 1, 2, 3, dot, 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 and it could keep counting as high as we could count. Number 8, it says x, such that x is an integer and x is less than or equal to 5.
5,
So where do we start?
5.
5. Less than 5 would just be 5, 4, 3. And you keep going and 3 dots. That would be set builder. So 9.1 is an easy section, so there's only going to be a 9.1a. We're going to get right to 9.2 tomorrow because these are kind of review sections here. So